So we started work on VR technologies with Mars missions. We are part of the subsystems on Mars rovers MIR, MSL, and Phoenix lander, and going forward with 2020, that we generate imaging data products, and part of that daily rover planning data sets that we produce 3D meshing products. And so those are polygonal meshes produced both from rover cameras, and as well as they're produced from the orbital dataset, such as HiRISE camera on MRO. And so for years we are used to seeing those products on a normal visualization in normal visualization environments, and basically had the idea how the user interface works, how to load the meshes and everything. So once we started to use try to use the VR hardware, so we started to see the difference. It's like how it's different from seeing it on a flat screen, and what advantages you get, and what both engineers and scientists are gaining by utilizing VR hardware. And so we created a prototype where we loaded our meshes, and we picked Unity game engine as our platform. So we loaded our meshes, we loaded model of the rover. We started to develop a user interface where we'll have basic controls. It's like in what direction you're looking at, what the reticle will show you, and putting it all together. And it was a very interesting experience to show it to our users and see how the whole workflow is different from the normal graphical application, and what advantages VR was offering. And then we started to see who are the potential users are. So we identified multiple teams on Mars rover projects, and some of them are listed here. Like for localization team, it's a very good way of actually trying to register different data sets. Like you receive new data from rover, and how it registers to the orbital data. The camera sequence creators, they would use it to create a better sequences, and also figure it out like what a good time of day to do the specific scientific observation, and also if certain pointing will collide with the rover hardware. And so it's we started to see that a lot of teams will gain a lot by using these VR applications, VR way of doing operations. And in addition to starting using VR, we see that something like a Unity game engine or Unreal game engine, the platforms, give us other advantages that existing platforms don't have. For example, it's much easier to do applications which you can deploy to multiple platforms. You can do it on desktop, you can do it on mobile, you can do it on the web. and for something like rover operations, it's very useful. Sometimes if you are not at work and you need to access the data from remote location, like if you can do it with your phone, that's very, very useful. It's like sometimes you can reach the person who is the domain expert, but who only has a phone with them, and for them to be able to use this 3D data is very, very useful. The rendering performance of the game engine also is something which is um, very, very useful to us. Our polygonal meshes consist of millions and millions of polygons, and the ability to display those big data sets and easily to use it. The performance we were getting with Unity was much better than with other technologies. The VR support is, of course, that's what drew us to using game engines. The support for game controllers and touch devices, that's one thing that we see, that basically the whole workflow is very different once you start to use game controllers and the hand controllers, especially hand controllers. It's like you can do so many things very different from when you can use only keyboard and mouse. It's like how you measure distances, how you you try to create your field of view. It's something that we only start to explore, and that's where the outside, how the gamers do it, is very useful to us to see, and that's something that we intend to spend more time in the coming months or years. The animation system, we were able to easily bring animations created in modeling applications into our environment. We would create animation in Blender, and it would fit very well into the Unity environment. And that's also something we didn't have with the previous software environments. The physics system, particle systems, we are at the very beginning to explore the benefits of those things and how powerful they are. And it's just we realize how powerful those systems are, and we intend to take advantage of them. So once we created the prototype, we showed it at several conferences, and the feedback we were receiving from users was very positive. And it was nice to see that how data from Mars rover missions, how well it's suited for VR, and how users were able to grasp the data, like the non-scientists, non-engineers, how they were able to grasp the data and have this feeling to be able to say that, oh, look, I'm on Mars. So after we did this prototype, we started to explore other applications of VR data and lessons learned making it working for Mars rovers, how we can adapt it to other missions. And so this one, we talked to scientists on the AIRS mission, and they got very interested in getting their data into the system. So we were able to get data which was also mostly put together in Blender. We were able to bring it in Unity and create simple controls how to fly over the data. So this one, if it's going to play, let me go back. Yeah, this is the web version of the Unity build with the AIRS data, and it shows different data sets from AIRS, and you can see that on one side of the data set, this, the hurricane is forming. shown together. And while this one, the movie itself is a flat screen, we got very positive feedback from scientists saying that to be able inside the data and to change the scale at which you're looking at the data, provide them capabilities that, for example, when the same data set is or other non-VR applications, they would not get the same information out of it. Another application we're exploring is for OMG mission, which is ocean melting Greenland. So they have data which is they use ships to go between fjords in Greenland, and they collect data at different locations. And and then they map the bottom of the ocean with the bathymetry data, and there is also data of the Greenland itself. From the DM, we created the actual 3D mesh out of it. So we created, using their data, we created another prototype where we would show them the map of the ocean floor and also the Greenland surface. And we are working with them with bringing more data. And so for them, we envision that we'll be creating crosscuts like based on the path of the ship. We need to show path of the ship, and then create the crosscut sections and so scalar and vector data. Like example of scalar data would be a temperature at different depths of the ocean. And again, those things, the game engine provides us a lot of tools how to do it efficiently and relatively easy. And with VR, it brings this also benefits that are very very useful to them. The future plans. So we plan to develop general visualization representations that can work with most 3D datasets, and those datasets could be terrains, scalar, vector morphology. We want to work on developing standardized, optimal and intuitive ways of navigating these datasets, and also standardized ways of using input devices such as game controllers and hand controllers. Also, we want to be hardware independent as much as we can, and so we want to leave it to users to decide what the best hardware for and what their preference is. It's again, by talking to users, users have very strong preferences. Some of them wants to use Oculus, some of them wants to use HTC Vive, some of them wants to use their phone with the Samsung technology, and those preferences usually very strong, and we don't want to we want to accommodate that hardware and allow them to use it, as opposed to saying that we have some preferred hardware to use. So in terms of implementation, we see that we need to invest a lot of time in implementing how we load the data, users' data, how we optimize the rendering and interaction of data sets for the specific applications. We want to implement most intuitive and easy to learn user interface, and make user experience tailored for specific applications and tailored for immersive visualization. And we want to be able to enable new missions to easily add their data to our environment. And in terms of mission, as I mentioned, that for Mars we want to meet specific science and planning and operational needs for future Mars rover missions, such as M2020. For the air scientists, we want to allow them to study weather phenomena, including frontal systems, hurricanes, and others. And for OMG scientists, we want to allow them to view their temporal and vector data sets. So that's all I have, and I'll be happy to answer questions.
Oleg, that was really fantastic. Thank you.
It's a pleasure to present today, and I thank Christian for inviting me.
Thanks a lot, Oleg. Appreciate it.
I have a question for you, Oleg. This is Shana. So do you have any of these applications in production as part of the missions, or are these more proof of concepts that you've done, sort of showing people the capabilities?
It's still at the proof of concept stage. We are based on this proof of concepts, we submitted proposals that are hopefully will be funded, and we are trying, because it's hard to get from the missions which already have been budgeted and everything, money for brand new things such as VR visualization. It's that's what we are finding out, that we need to plan ahead, that we finding money which will be available in a year or two from now, and based on that we'll start to generate applications that will be in production. Mm-hmm. But it's hard to come to existing missions and say that here is here's this what's going to help your scientists and engineers, but we need the budget right now. Yes.
Yeah, that's been our experience as well. Is, proof of concept, they can find some sort of innovation research type funding, but to actually put things in production and get money from the missions is more difficult.
Yeah, but it's we are expecting to get funding that will get us going. Probably not this year, but hopefully starting next year.
Great.
And also, I would like to mention that a lot of this work we started working with the students, and that's another advantage of doing stuff in Unity. We find that it's a lot of students that are currently at school or just finished school. They're very well aware, have skills working with Unity, and very well suited for this work. And it's also something that when you advertise opportunity, whether it's for summer internship or some other opportunities, that students are we get very top of the crop students who are very interested to work in this area, and who have great skills in this area.
That's a great point, and could be something that people from other organizations could keep in mind if they're trying to figure out how to get up and running and do their own proof of concept or their own pilot project, is to think about using a partnership with a university. A lot of the universities do have programs now for game development, and those skills are definitely applicable to this. So I think that's a great point to consider.
Yeah, definitely.
Hi, it's Justin from Goddard. I'm sorry.
Sorry, I was going to say that this this video game development skill, it's pretty new, so it's hard to find people that have the experience necessary to do VR development. So yeah, working with universities would be a great idea.
It's Justin from Goddard. I have a question. How difficult do you think, or any challenges you think you may face by extending this to a different application space?
Depends what's your application space. It's like the game engine environment depends on your data sets. If your data sets are like polygonal meshes, points, clouds, any kind of other 3D data, then there are very good ways of getting that data in. You might have, if your application space does not fit those data sets, then it might be more work of basically just figuring out how that data should look like in immersive environment. And for us, it was basically a lot of learning. It's like when you work with Martian terrains, it's very different when you work with cloud data, and when you work with the cloud data, it's very different when you work with data from OMG, so which is either ocean floor or it's scalar data at different depths. So yes, understanding the data is a big part of coming up with the right system for using the data and visualizing the data.
Okay, so follow-up question to that. For science data applications, do you think the data would have to be transformed or collected in some kind of way so you can easily do something with it, or no?
Yes, I would think that you need to transform the data to the format that is best suited for something like ingestion to Unity game engine or other game engine. It's like if it's a multiple data sets, a lot of or some of the work involved in co-registering different data sets for them to be in the same coordinate system. Like if you have observations coming from different instruments, different spacecrafts. And some of those tools already exist, and it's just checking them. For example, we envision that using W10N would be very useful to us. So in that way, a lot of stuff already is available that would make using immersive visualization not starting from scratch. Yeah.
Okay, thank you.